or split into 5, 1, 2, 3, 4, 5, is at about 1.5, we'll call it. Oops. 1.5. Yeah.
Isn't it the 1.4?
1.4 is.
Oh, no, I did it right.
2.6.
I'm sorry, I didn't see your ratio.
So that's 2.
That's on your
Split by.
Yeah, now this is split into 6, so there's got to be 2 on one side and what? 3 on the other. So this guy is at 1.4. And notice that this guy could be that guy. Does that make sense? Now this one here is split only by 2 hydrogen neighbors. This thing right here is a triplet and it's at about 2.6. So far, so good. I'm going through this kind of fast, but hopefully you're following what we're talking about. It looks to me like we've got our compound. You may not think that we've got our compound. But if I take that and attach it to a benzene ring, we're there, like this. Like that. This will only have 2 hydrogen neighbors because there's no carbon here, or no hydrogen here. So it'll be split into a triplet, and it'll be further downfield because of the influence of the ring. True? This guy will be split by 4 neighbors into a quintet. This guy will be split by 5 neighbors into a sextet. This will be split by 2 neighbors into a triplet. That structure is consistent with what we've got up there. And again, what we did is we looked at the splitting pattern and said these structural features have to be present in the molecule. And then just assemble them appropriately. This is a logic exercise. I'm very fond of it, obviously you can tell, because I think it tests your analytical skills and forces you to develop them a little bit, because you have to look at some disparate pieces of evidence and figure out how to make them come together and be consistent with the structure that you propose. How are you doing? Just, yeah. Yeah, the only neighbors it has are these 2. That would be right here. The 3 hydrogens is kind of cut off because when I blew it up, but this is a triplet, 1, 2, 3. And we could, if we had really high resolution equipment here, we could actually look at coupling constants. What are coupling constants?
The width of the piece.
Splitting distances. For example, this guy, CH3, is going to be split by this guy, which is the thing at 1.4. So I could actually blow this up and measure the distances, and if they're the same, we've got it.
Oh, so 1.4 peaks would be the same, okay.
Does that make sense? Now, we know this particular spectrum, which was out of a book that comes from 1979 or something, didn't have that kind of technology available to them at that point. So, but just recognize that if you work in a facility where they've got high budgets for NMR equipment, that kind of coupling constant analysis could help you as well. All right? Now, one last thing. Let's look at the structure we've proposed here, and let's figure out how many different kinds of carbons are present and predict what the NMR should look like. Okay? I would suggest that each one of these is different. So there's 4 in the chain. There's the kind that's attached to the ring, kind that's next door to that, and all the way out. All 4 of them are going to be different. This will be a 5th type right here. These will be a 6th type, 7th, and then 8th. The C13 NMR spectrum ought to have 8 signals in it. Does that make sense? Because there appear to be, based on what we've drawn, 8 kinds of hydrogen, or 8 kinds of carbon. Let's see if that's what we see here. Here's the C13. And again, we ignore the deuterated chloroform. And so I've got 1, 2, 3, 4.
Oh, this one.
You're right, I've only seen 7.
But they said on a double Z, they blow up.
Oh, one of them's double, okay. One at 129 or so is actually a double. This one. So there are 8. Now, let's test our analytical skills a little further. Why are these 3 way down from there? They're the 4 that are part of the ring. Okay, and so there's that one, this type, and this type. So the 4 type, there's actually, we have 2 buried under this peak, and then there's this and this. Those are going to be the aromatic carbons, and then the ordinary hydrocarbon chain will be over down at the other end. Watching me do this doesn't make you good at it. What does make you good at it? Doing it yourself. Stretching yourself and figuring out how to come up with these kinds of answers is the only way you're going to get to where you can come up with the So, is this constructive?
Oh, yeah.